Hello everyone, it's Miss Gergen, and today we're going to learn about solving quadratic equations in the real world. So when we have a parabolic function, right, this U-shaped curve, that exists in the real world, and there are many points in time on that parabolic function that we can solve for. So today we're going to go over a few and how we would do that algebraically. So we have our problem. Sean shoots a marble into the air from ground level. The function that models this scenario is h of t equals negative 16 t squared plus 48t, where h is the height of the marble in feet and t is the time in seconds. How long until the marble hits the ground? So we are presented with our first question. The first step would probably be to kind of sketch out the graph. So let's take a look here at the graph. I graphed it on Desmos, the free graphing calculator. So I just typed it in and you can see our parabola, right? And you can see that it starts at the origin, right? 0, 0. It's going to go up and then because of gravity, eventually it'll come down and hit the ground, right? So let's talk about that. The question asked, when will the marble hit the ground? The key word here is when. When means time, right? When, time. Time is usually represented by the x-axis because x is our independent variable and time is independent, right? So I'm going to label, you can see here I labeled our x-axis for time in seconds. Now, the y-axis is going to be the height of the marble, right? So we start at 0, 0, which is labeled A, and then it will shoot up. The marble will shoot up, so the height will increase, right? Eventually it'll curve, and then it will come back down and hit the ground, right? So we want to know when. But when what? When the marble is on the ground. Okay? So what are the steps to solve for this algebraically? So let's write down the equation. H of t equals negative 16t squared plus 48t. We know that we want to know when the marble is on the ground. So that means that its height is 0. So we're going to set h of t, which is the same thing as y, we're going to set it equal to 0. Now we're going to factor, but this is not a quadratic function in standard form. So really, we can only use GCF, greatest common factor. So what are both negative 16t squared and 48t, what are they both divisible by? How can I simplify this? Well, they're both divisible by negative 16t. So that negative 16t is going to come out in the front. We're going to divide it out. And when we divide the first term by negative 16t, we will be left with t. When we divide 48t by negative 16t, we will get negative 3. That's factoring using the greatest common factor. We just divided what they both had in common and moved it to the front and simplified. Now we're going to split it into two different problems, right? So let's look at the left-hand side. We have 0 equals negative 16t. We want to isolate our t. So that means we can divide both sides by negative 16. So if I divide by negative 16, the negative and the 16 cancel. If I divide 0 by negative 16, I am going to get t is equal to 0. On the other side, we have t minus 3 equals 0. So I'm going to solve for t. So I want to isolate the variable, the t, and move the negative 3 to the other side. How do I do that? By adding 3 on both sides. That causes the negative 3 and the positive 3 to cancel and leaves us with t equals 3. Okay, so what does this mean? Let's analyze our answer for a viable solution. We do know we have two answers. We saw it in our last graph that on the parabola, it is on the ground when it starts, when time t is 0, right? But that's not what we're looking for. The question asked us, he's going to shoot it, and when will it hit the ground? How long will it take to come back and hit the ground? It was t equals 3, which means that it will take 3 seconds for the marble to hit the ground after being shot up. So you can see it on the graph. Again, the solution, this is where it started, the 0. So we already knew that. It started at 0 seconds, 0 feet. It got shot up, but how long did it take to come back and hit the ground? This will hit the x-axis at 3, which means it will take 3 seconds. Okay, so more questions we can ask. So using the same problem, there are other points in time on that parabola, right? So we already talked about when it hits the ground again, right? But what about when will it reach its maximum height? So maximum height, you should be able to relate that to what? The vertex of the parabola, which is this point all the way up here, okay? So when will it reach its maximum height? When will also be time, right? X, because we already talked about when, meaning time. But they can also ask us what is the maximum height, which is how high up are we up here? So let's try that out. So let's start with when, because we already solved for X. Let's do it again. When will the marble reach its maximum height? Well, when is the X, like I keep saying. When time X. That helps because at least we know which letter, which variable we're solving for, X or Y. It's X. And again, maximum should spark in your mind something mathematically is the vertex, right? So what point corresponds to that? The vertex. Okay. So the vertex. What is the formula to find the x value of the vertex? Well, when you have the equation in standard form, ax squared plus bx plus c, which is what we have, we use the formula x equals negative b over 2a. That helps us find that axis of symmetry, that invisible line down the middle, which is x equals, and it's the x value of the vertex. Our vertex is our minimum when we have our parabola opening upwards, or our maximum when it is opening downwards, like we have in our situation. So we have our equation, h of t equals negative 16t squared plus 48. So our a is the negative 16 because it's in front of the t squared. Our b is the 48. So we're going to plug it into our formula. So we're going to get negative 48 divided by 2 times negative 16. When I multiply 2 times negative 16, I get negative 32. The negatives cancel, right? A negative divided by a negative is a positive, and we get 1.5. So what does this 1.5 represent? It will take 1.5 seconds for the marble to reach its maximum height. Okay. Now that we have the x value of the vertex, which tells us when, time, the marble will reach its highest point, that brings us to the last question. What is the maximum point or maximum height that the marble will reach? We don't know how high it ever got. So if we're talking about height, maximum height, we need to find the y value of our vertex. So find the y value of the vertex. Okay, so what is the maximum height? We know that the x value is 1.5. In a coordinate, right? A coordinate is made up of x, comma, y, right? And we want to find that peak, that highest point on our parabola. We already know the x. We need to find the y. So that means that we have to plug in the x, the 1.5, so that we can solve for y. Now again, in this problem we're using h for height, t for time, but you need to keep in mind x means time, so it's the same as t. So that's why I wrote, remember, x or t is 1.5. Okay? So I plugged it in for us in parentheses. Every time you plug in, you want to plug it in parentheses. So we have h of 1.5. So that means that just is a function notation for saying the height when 1.5 seconds has passed is equal to negative 16 parentheses 1.5 squared plus 48 times 1.5. So PEMDAS, order of operations, we are going to start with the exponent, and the exponent is on top, here's our little exponent, of the 1.5. So we have to do 1.5 squared. 1.5 times 1.5 is going to give us 2.25. So we did an exponent in PEMDAS E. Now we can multiply. So we can multiply the negative 16 times the 2.25 and the 48 times 1.5. So we end up getting negative 36 plus 72, which gives us 36. So we have h of 1.5 equals 36. So that means the height after 1.5 seconds have passed is 36 what? 36 feet. So that is the highest the marble will ever get because this is the maximum. We saw for the vertex, which is the max. So let's see how that looks on the graph. So I have marked all the points we've discussed. The first point we discussed was our A, which was our 0, 0, the origin, which is when no time had passed yet, we haven't done anything, and the marble's on the ground. And we shoot up the marble. It goes up, 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 and it reaches its maximum. The time is the x value there, which is 1.5. The height, how high up it is the y value there, which is 36, which we found algebraically by using negative b over 2a to find the x, and then using that, plugging it in to find the y. And we also found our b down here at the bottom, which is when it finally came back down and hit the ground, which was 3 seconds later. So that concludes the questions that I wanted to go over regarding our marble, but there are many questions that they can ask you in a real world situation. So it says, from what height is the object launched? That is the same thing as the initial value, which is the y-intercept. Your y-intercept is usually the c in the ax squared plus bx plus c. But since we had no c, we had no constant, that means it was at 0, which we saw. It started on the ground. It said that in our problem. So that's why we didn't have that. Now, number 2 says, how long does it take for the object to reach its maximum height? We did that one. That's how long, so time, so that's x. And to reach maximum, you got to think maximum relates to the vertex. So that's when we use the x equals negative b over 2a. Another question they can ask us is, what is the maximum height? What is the maximum height? Again, we substitute the x value. We did all that. Okay, how long does it take the object to hit the ground? You are usually going to factor. We use GCF, but we can do any type of factoring, or you could use the quadratic formula. When in doubt, you can always use the quadratic formula to find when it hits the ground, because that's when it's set equal to 0, right? Ground level is 0. So you can also use the quadratic formula if you can't remember how to factor. And when does the object return to a height of 3 meters? So if they ever want to know, like, when is it at a certain height in its path, right? Because the marble travels, right? It goes up and then it comes back down. So let's say if they ask for, like, we know in our problem the peak was 36. But what if they ask us when will it be at, like, 10, right? 10 feet. How do I know when, like, what x value it was there? Well, I just plug in to the height. Instead of plugging in 0 to find when it's on the ground, I would plug in that height and put it in standard form and factor again and solve for it. So those are different questions they can ask us. The best thing you can do is graph it, sketch the graph, and try to understand, what are they asking you, x or y, time or height. I hope you enjoyed this video, and I hope that helped you guys to solve real world problems, because this algebra is applicable in our real world. Thank you.